Hi, for this video, let's discuss laws of logarithms. Before anything else, let's have some of the basic rules. Number one, logarithm of a product. If, for example, here you have a product of x and y with base b, what you can do is you can separate this as a sum of two logarithms having the same base. For example, logarithm of 6 base 10, you can say that 6 is a product of 2 and 3, and then you can separate them as logarithm of 2 base 10 plus logarithm of 3 base 10. Just like for ln of 2 pi, you can say ln of 2 plus ln of pi. The second law, logarithm of a quotient. If you have, for example, logarithm of x over y base b, you can separate them as a difference. Logarithm of x, the numerator being the first term here, base b, minus logarithm of y, base b. Example, logarithm of 5/7 base 3. You can say that that is logarithm of 5 base 3 minus logarithm of 7 base 3. For the third law, logarithm of a power. If you have here, for example, logarithm of x raised to m base b, you can bring down the power m to the front. So logarithm of 8 here, you can express 8 as 2 to the third power. 3 goes down in front. This can be expressed as 3 logarithm of 2. Take note that if the base is not specified, it's understood to be base 10. In here, logarithm of 16, so that's ln, natural log of 16. 16 can be expressed as 2 to the fourth power, so this becomes 4 ln of 2. Similar to number 3, logarithm of an nth root, what you can do is first express the root, the radical, as an exponent. So that can be 1 over m or any power over m. You can bring this down in front. For example, logarithm base 5 of the cube root of 9. What you can do is that 9 can be expressed as 3 squared. So that's the cube root of 3 squared. This one is actually 3 to the 2/3. So the 2/3 can be brought down in front. Some other properties of logarithms are logarithm any base of 1, if the argument is 1, this is equal to 0. But you have to take note that base b should never be equal to 1. It can be greater than 1, or it can be greater than 0 but less than 1. It cannot be equal to 1. So, if for example, the argument and the base are the same, basically this is an identity that's equal to 1. So, for example here, logarithm of 10 base 10, that's equal to 1. Also take note that the logarithm base e, where e is the natural number, is actually the ln, natural log. Therefore, natural log of e is also equal to 1. For property C, this is actually called change of base. So change of base. For example, you have logarithm of x base y. You can separate them as logarithm of x divided by logarithm of y, but then both logs have to have the same base. So you can see in here, both are base 10. In here, both are base e, so both are ln. So, for example, in here you have logarithm of by 5 base 0.1. That was written as logarithm of 5 divided by logarithm of 0.1, where their bases are both 10. Or ln of 5 divided by ln of 0.1. And the answers would be the same if you press them in your calculators. Some other properties are these, D and E. For example, the argument is raised to x. You know that one of the properties of power is you can bring down the power to the front. And then if the base and the argument are the same for the log, this is actually an identity. So that's x times 1, just like an example in here. logarithm of 7 base 7, and that 7 there, the argument is raised to 1 half. 1 half can be brought down in front. And then logarithm of 7 base 7 is actually equal to 1. Similarly, for this case, you bring down 51, that's logarithm of 2 base 2, that's 1. In here, ln e raised to x, you bring down x, and then ln of e is 1. For letter E, this is somewhat similar to letter D. The base is raised to a logarithm, but the logarithm has the same base as the original base in here. So for example, 10 raised to the logarithm of x base 10, it sorts of like cancel out this one. You're left with x. Similarly, if you have e raised to ln of x, that's x. E raised to ln of 6, that's simply 6. So those are some of the few properties of log. And then here in the next slide, I'm showing you some of the most common mistakes wherein, for example, you have logarithm of 5 plus 2 base 2. They distribute that. It's not allowed to distribute the logarithm. So you cannot just distribute that. That should be logarithm of 7 base 2, but you cannot do this. Similarly, number 2, you cannot just separate them as a product. Number 3, you cannot separate those. It's not distributive. So let's just have some exercises. Use the properties of logarithms to expand each expression. So let's go to number 1. For example, you're given logarithm of ab squared. So it's a product. What I can do is logarithm of a plus logarithm of b squared, and then I can still simplify this as logarithm of a plus 2 logarithm of b, and then I won't simplify it any further. That's where I end. Number 2, you can see there you have logarithm base 3 of 3 over x to the third power. That is a power, so I can bring it down in front. I'm left with logarithm of 3 over x base 3. Since there's still a quotient there, I can separate that. That could be written as logarithm of 3 base 3 minus logarithm of x base 3. And then take note that one of the properties is that if the base and the argument are the same, that is actually equal to 1 minus logarithm of x base 3. So I can say when you separate them, you can separate them like this. You're given number 3. For example, ln of x times x minus 5. Some of you might say, is it possible to distribute that? It's okay, but then since it's already separated, you could apply them into the given. So ln of x plus ln of x minus 5. Again, you should end here. You never distribute that ln term there. Next, logarithm of 9x to the 4y all over the fifth root of y. So what we did here was we clumped all together the numerators. So that is written as logarithm of 9x to the 4y minus everything in the denominator. Logarithm of fifth root of y. And then each of the terms in the numerator, 9x to the 4y, was separated as a sum. So logarithm of 9 plus logarithm of x to the 4 plus logarithm of y. And then this one, as I have said earlier, logarithm of y raised to 1/5. The index here is 5. So logarithm of 9, and this is 4 logarithm of x, logarithm of y minus 1/5 log y. Some people stop here, but some people, what they do, this can be written as 2 logarithm of 3 because that's 3 squared. But, no one is stopping us from doing this. But for some who answered this one, the one I'm writing, that's also acceptable. Next, for number 6, let's try solving. ln of 16 square root of 2 e to the negative 4 all over x plus 1 squared. So what we can do here is everything in the numerator, let's group together first. And then everything in the denominator, let's group them together. So for the numerator, I can make them a sum, ln of 16 plus ln of the square root of 2 plus ln of e to the negative 4 minus ln of x plus 1 squared. So 16 is 2 raised to 4. So I can say this is 4 ln of 2. This one is 1 half, right? So 1 half ln of 2 minus 4. Take note, you have here ln of e minus 2 ln of x plus 1. So some of you might say, is it possible to combine this and this because both of them are ln of 2? Yes. Take note that this one, ln of e, that's equal to 1. So when you would want to combine them, you can say 4 and 1 half. So that's 9 over 2 ln of 2 minus 4 minus 2 ln of x plus 1. So you can write it like that. Okay? Now let's go to this one, wherein what you are given is a separate term or separate terms here, and then you're asked to combine them or condense them into a single logarithm. So we use the properties, it's backwards now. For example, logarithm of 5 plus logarithm of 3, you can say logarithm of 5 times 3 or log 15. In here, 2 ln of x minus ln y, first you can raise this to the second power. So ln of x squared minus ln of y. So that means since there's minus, the term in here, the first term becomes the numerator over the denominator. But do take note that the square term only affects x squared and not the y. Similarly, for number 3, do take note that they have to have same bases for you to combine them. So some of you might ask, what about number 4? Number 4, it's just 2 minus logarithm of 5. There's nothing written there. Take note that for number 4, you can say 2, and then it says there logarithm. It did not specify anything. So I can say, even if I don't specify the base, it's understood to be base 10. That's why you can say logarithm of 10 squared or logarithm of 100 is the first term. That's why you have here logarithm of 100. I'll show you. It's this one. That's why you had that. And then they have the same base, base 10. 100 over 5, that's basically logarithm of 20. So here, it's easy because all the bases are the same. You can combine the positive to the numerator and then all the negatives as a denominator. That's why you have this. So let's try this one. Suppose logarithm of 2 is equal to a, 3 is b, and 7 is c. Express the following in terms of a, b, c, and so on. Okay, so I can say logarithm of 18 is 2 times 3 squared, right? 9 times 2 is 18. Therefore, I can use the properties of logarithm. So logarithm of 2 plus logarithm of 3 squared. So I'll rewrite them first as logarithms. This is 2 logarithm of 3. Now looking back up, logarithm of 2 is equal to a. So I can say that that's a. Logarithm of 3 is b. Therefore, this is 2 times b. So that would be it. Now in here, log of 56. 56 is 7 times 8. Therefore, log of 7 plus 3 logarithm of 2. So log of 7 is c. 3 log 2 is 3a. Therefore, the answer is c plus 3a. Let's go to another one. Logarithm of 14 over 9. So I can just say logarithm of 14 minus logarithm of 9. But 14 is logarithm of 2 times 7 minus 9. I can say that this is 2 logarithm of 3. This one is log 2 plus log 7 minus 2 log 3. And then let's express each. This one is equal to a. Logarithm of 7 is c. And then 2 logarithm of 3. So that's 2b. You understand? Okay. For number 4, logarithm of 10 over 5. So I can say this one is 21 divided by 2. Logarithm of 21 minus logarithm of 2. 21, I can write that as 3 times 7 minus logarithm of 2. So this is log 3 plus log 7 minus log of 2. So logarithm of 3 is b, logarithm of 7 is c, minus logarithm of 2 is a. So those ones. So I'll leave you with 5 and 6. Basically, that's it. Thank you very much.